Okay, to meet my expectations today, you're going to have your homework out from yesterday. You're going to have paper for notes out and have a pen or pencil out to take those notes. If you're someone who likes to color code your notes, you would also want to have your highlighters or color pencils out. So you should be looking at this assignment in front of you on this side, and let's go ahead and correct this together. Are there more seeds in Fuji apples or Washington apples? Is that a testable question? Could you collect data on it? Absolutely, you could. You could set the test up, you could count the seeds in the apples, take multiple samples of each kind, etc. So yes, testable. Number 2, what types of apples grow in Missouri? I guess you could take a road trip to Missouri and find all the different kinds of apples, but really that's not a test or an experiment. No, this is really what I like to call Google. Just Google it. Number 3, why do people smoke? This is an opinion. They all have different opinions on why they smoke, and this is actually something that you could Google from some surveys that they've done. Number 4, how does talking to a plant affect a plant's height? Could you collect data and form a test on this? Absolutely. Talk to plants and measure their growth. Number 5, where are whales found in the world? Again, that's going to be a Google question. Number 6, what happens if you do not eat breakfast? This is going to be, it's not exactly opinion, but it's just subjective. It depends on the person. Some people do better, some people do worse. It's really not a question that you would test and grab data on. So again, ask Google. Number 7, which planet is the most interesting one to study? Interesting should always be a red flag in science because that's going to tell you that it's an opinion. So no, this is not a good testable question. It's an opinion. Number 8, which objects are attracted by a magnet? Paperclip, penny, foil. Could you conduct tests on this? Absolutely, and collect the data. Number 9, will larger or smaller seeds germinate faster? We're talking about speed, and absolutely you could plant them, water them, and make observations, so that one should be circled. Do larger or smaller seeds make prettier flowers? This one, prettier, is that keyword right there that tells you this is an opinion. Some people don't even like flowers at all. Number 11, do flying saucers really exist? Flying saucers meaning UFOs. I think we've changed the names of them since then, but is this something we can collect data on or test? No, we can't. So it's not even an opinion either, and if you Google it, you're going to get some really weird ideas. So I'm just going to say this is an alien question. Number 12, which pill design, tablet, caplet, or capsule will dissolve faster? You absolutely could test this, time it, and collect data. Does the color of a surface affect its temperature? Again, affect is one of those key words that tells you, yep, this is going to be a testable question. You could set it up. In fact, I had a student one year do this for science fair. He bought just a huge variety of colored tiles and put them out in the sun. And he took the temperature readings at various times and got results from that. All right, number 14. Why does doing homework help your grades? Whenever you see the word why, that's usually going to cue you in most of the time that that's not going to be a scientific testable question. That, again, ask Google. Number 15, how does the size of a helicopter's blade length affect the speed and number of rotations? If you have access to helicopters to test and you know the safety protocols, then absolutely you could test this. Does the temperature of a classroom affect student performance? There's that word affect, and absolutely you could do this. And I'm going to tell you it absolutely does. And that's why I keep my room cold. Keeps you awake, keeps you focused. Number 17, how does talking to a plant affect the plant? And I think we already had that one, so yes, we know that that's absolutely a testable question. All right, at the bottom, I'm going to grade those questions, and the ones on the back where you wrote your own questions, because there's so many variances that could be there, I'm going to grade those on my own. So if you would pass these up to the front or turn these in to your teacher so that those can be thoroughly graded. After you've done that, I want you to go ahead and have your paper and pen or pencil and highlighters out, and go ahead and draw a line in your notes, date your new entry, and this is going to be the variables. This is step 2. All right, so to get you thinking about this and get you thinking about the reasons why, what's the first thing kids scream in a situation? Not even kids, not even just kids, adults even. Well, the first thing they scream in a situation is, "That's not fair." And I know this is a fact. Absolutely, because I've raised 3 kids and I've taught for years and years. You think, "Oh, I'm going to be such a nice mom and make my kids some brownies and put some frosting on there and then put sprinkles on there, and I cut them up and put them on plates and put milk out and say, 'Hey kids, come up and get your snack.'" And they come up and they run and they say, "Yay, it's brownies." They sit down and they're about to take a bite, and all of a sudden they look at it and they say, "That's not fair. She has more sprinkles than me. You love her more. You gave her more sprinkles." That is absolutely the case. And adults feel the same way. They want things to be fair. Why did so-and-so get that promotion? I work twice as hard as he does. So we're looking for equality, for things to always work out. We want justice. Well, that's where scientific variables come in. Variables are the rules that you decide on for an experiment. Go ahead and pause the video right now and write this definition down. Variables are the rules that you decide on for the experiment. There are 3 kinds of variables, so I would certainly write this phrase down in your notes. 3 kinds of variables. Pause the video and write that down. All right. The first kind of variable that we're going to talk about is the independent variable. The independent variable. This is something that is changed by the scientist on purpose. You, the scientist, are going to change this on purpose. This is literally what you're testing. This is why you have the whole test. It's also what is manipulated. The word manipulate means to change. I know in our society, a lot of times the word manipulate has a really negative connotation. It usually implies that somebody's being crafty or shady to get you to change your mind. But that's not what we're talking about here. We're using it in a way that simply means just to change. Go ahead and pause the video right now and write this definition down. As we go along through this, we're going to develop 2 different topics and keep developing it all the way through. And so I'm going to use football and plants. Okay, so let's look at football first. The independent variable in football. What are we changing on purpose? What are we going to keep changing and test? Well, we're going to change the different plays. You're going to have multiple plays that you're going to try on the other team. And you're changing them on purpose. It's not an accident. Your coach is going to call different plays as you go out there to play. Likewise, in plants, we're going to do we'll think about a test where you're going to test the liquid that the plants drink. And so your question might be, does the type of liquid a plant drink affects how well it grows? So your independent variable, or your IV, is going to be the 4 different liquids you chose to test on 4 different plants. You're changing that on purpose. The next one is your dependent variable. Dependent. And dependent means you need something. You guys are still dependent on your parents. You need your mama to go to the store and buy you Fruity Pebbles cereal for breakfast. You need your mom to go buy deodorant and soap for you, and please use it. So you still need them. And so the dependent variable needs the independent variable. And the way that happens is that the dependent variable is something that's affected by the independent variable. It's basically, you guys, what you observe, what you measure, it's your data that you collect. And you're going to be really specific about the way you're going to collect it. You're going to say, hey, I'm measuring these in inches or in centimeters or degrees or whatever. So go ahead and pause the video right now and write this definition down. All right, back to our football and plant scenarios. So we said that the IV for football, or the independent variable, is we're going to change the plays up on the other team. So if we're measuring, or what we're observing is our dependent variable, we're seriously going to just see, did it work? We did this play. Did we get some yards? Did we get a touchdown? That's our data we're collecting. With plants, that should say DV. I'm sorry, I didn't change that. And I did the same thing with the plants. Your plant is how much they grew. Your DV is how much your plants grew. Okay, the one that was fed orange juice, it didn't grow at all. The one that was fed water, look how much it grew. And you're going to be measuring and recording that data. The last one is going to be your controlled variables. Your controlled variables. And these things, the word control means to keep the reins on it, the rules, to make it behave. So a variable that's not changed, they can't change. And they're also called constants because they're constantly in place. You guys, these are the rules that make it fair. These are the rules that make it fair. So pause the video and write this definition down. Back to our two scenarios, the football and plants. In the football scenario, we tried different plays. Those were our IVs, and our DV was measuring, hey, did it work? How many yards did we get? And all of that's fine and wonderful, but you've got to have rules of the game to keep it fair. So that would be all the things they put in place. And again, I have put IV, and it should be CV, the controlled variables. These are all the rules that make it fair and make it a fair game. You can't just clothesline somebody as they're running. You can't hold if you're on offense. So those rules keep the game fair so that when you try your different plays, your independent variables, it's a fair test. On plants, and again, I did the same thing. It should say CV. It's the equal opportunity that you give them. So I put this little picture of how to take care of plants. So we were changing the types of liquids, but you have to have rules to keep it fair every other way. Like they all have the same environment, the same amount of soil. They have the same temperature. They have the same amount of liquid. It's just a different liquid. Except, anything else that would keep it exactly equal or fair. Okay? All right, let's look at an example. Students who have different ages were given the same jigsaw puzzle to put together. They were timed to see how long it took to finish the puzzle. Go ahead and pause the video right now and see if you can figure out what the IV, the DV, and the CV are in this scenario. Okay, let's identify those together. What was the independent, or IV, the independent variable? Well, it was the ages of the students. They were different ages of students is what they said. Well, what was the dependent variable, the DV? They told you that it was the time it took to put the puzzle together. So they were going to time them, and that was going to be the data. That's how we kind of knew who won. So the controlled variable was going to be that they all got the same puzzle. You could even throw in some other things, like it had to be the same environment. They had to be treated the same when they put it together. They all had to have the same snack before they put them together. Anything you could do to make it fair and even. All right.